You'll recall that when we talked about variable declarations, we said that variables always had to have an explicit value assigned to them. That's not true for fields. Fields will get a default value automatically as part of the object construction. Now that default value will always be what I call the field's zero value. And what I mean by that is it's kind of whatever the kind of empty state of that field is based on its data type. If we take a look here, like for example, all of the integer fields, byte, short, int, and long, the value is actually 0. Same with the floating point, the value is 0. For the char type, the 0 value is basically, again, all zeros, kind of the null character. For Boolean, it defaults to false. And for reference types, they default to null. So we have all these kind of default values that they get, and those are all reasonable defaults. But as your objects get more sophisticated, those default values may not be the right thing for your object's initial state. Now the good news is we don't have to accept those default values. Java provides what are called field initializers. And a field initializer allows you to specify the field's initial value as part of its declaration. Imagine we have this class. We're going to call the class Earth, and it has a field called circumference in miles. So we want to go ahead and set that to an initial value, right? An initial value of 0 doesn't make sense. We know the Earth actually has a circumference. So what we can do is just do a simple assignment to set its initial value. So we can just simply say circumference in miles equals 24,901. By creating an instance of the Earth class, that field will have the value 24,901. Now, simple assignments are a good start, but that may not be enough. You can also use an actual equation. So if we had circumference in kilometers, well, we could calculate that out by hand, or we can simply say that, well, I know if I take 24,901 and multiply it by 1.6, that'll give me the circumference in kilometers. Right, so we can actually have that equation. Remember though that the equation has to be a valid equation. Right? So right now this wouldn't compile because although 24,901 is an integer type, when I multiply it by 1.6, which is a double, that result will be a double that I can't assign directly into the long circumference in kilometers. So we just go ahead and put a cast in place, and that now becomes a legal assignment. But if we look here, you see that we're duplicating that 24,901 in 2 places. It'd be nice to only use it once. Well, we can actually reference other fields in our field initializers. So we can take that 24,901 and replace it with the field circumference in miles. So the equation would then use the value of circumference in miles when it does the calculation. So things are kind of getting better and better as we go along here. Now, one thing interesting to note though, if we calculate out 24,901 times 1.6, the value that that calculates to is 39,841.6. Now, when we cast that to a long, the cast is just going to truncate it. So the value of circumference in kilometers would end up being 39,841, a less than ideally accurate. The better answer for that would be 39,842. Well, the good news is we can make any method calls that we need to in here. So one of the things we could do is there's a built-in method called math.round. So if we call math.round, that'll take the result of that equation to 39,841.6 and actually round it so that we then would get 39,842 into our circumference in kilometers. So you notice these field initializers are really powerful because you can do as much as you need to. Anything from a simple assignment through equations all the way up through method calls.